Hello, this is Brady. In this presentation, I would like to provide answers for some of the quiz 1 questions. I'm going to pick question 2, 4, and 5. Okay, so question 2. Prove that the following logical statements are logically true, and use the proof by contradiction. So in that case, we want to prove the statements are logically true. So that means using the proof by contradiction, all we need to do is to assume that if the expression is logically false, and then we can prove that this is not the case, and it leads to contradiction. Now let's take a look at the first one, 2a. So A is an implication, right? So we assume that the expression is false. Okay, so this is the implication. So if the result for the implication is false, that means the antecedent is 1, right? The antecedent must be 1, and the consequent must be 0. So by definition of the implication, if the result for the implication is 0, the antecedent, if and only if, antecedent is 1 and the consequent is 0. So then I call this is 1, and then 2. Now based on from 1, because the second expression is 0, and by itself, the second expression is implication by itself, right? So if this is 0, that means the antecedent is 1, which is P or Q, and the consequent is 0. So now we got R equals 0. And then also from 1, the first part of the 1, we got P implies R and the Q implies R is 1. So that's a disjunction, right? If the disjunction is 1, that means both operands must be 1. So P implies R equals 1, and Q implies R equals 1. I'm sorry, this is 1. So now we see that the from 2, we know that the R equals 0. And then from 3, we know P implies R equals 1. Now, what does that mean? So that means P implies R. R is 0, so P implies 0 equals 1. Now, based on the definition of the implication, so that means the antecedent P must be 0, right? If P is 1, then it's not going to be 1. P is 1, then this is going to lead the result to 0. So if its result is 0, P must be 0, right? And similarly, because also R is 0 and Q implies R is 1, so that means we can get the Q must be 0, right? So now we got a P equals 0, Q equals 0, and then we can get, I can say from 4, P or Q equals 0 or 0, which is 0, right? So we got P or Q equals 0. So that means P disjunction equals 0. This is actually the contradiction, right? There's a contradiction now, because from 2, P disjunction Q equals 1. But now we say P disjunction Q equals 0. So we got the contradiction. Right? That's done for 2A. Now for 2B, again, we try to prove that the expression is logically true. So that means we assume P implies Q implies, negation of Q implies negation of P, parentheses. Now assume this is 0. So again, this is the implication, right? So that means if the implication has a value false, that means antecedent must be 1 and the consequent must be 0. Now I call this 1. Now based on the second expression, so this is also the implication by itself. So the result is 0, so that means the from 1, the negation of Q must be 1 and negation of P must be 0 because the implication is false. So that means antecedent, which is negation of Q, must be 1 and the consequent negation of which is negation of P must be 0. So then from 2, right, we got the negation of Q is 1, so that means Q must be 0. It's the opposite. And negation of P is 0, so P must be 1. Right? So that means if Q is 0, P is 1, then what is P implies Q? P implies Q means 1 implies 0. Now, based on the definition of implication, they're going to give you 0, right? Now, what do we get? So this is this is a contradiction, right? Because from 1, we know that the P implies Q equals 1. So there's a contradiction. Right? Because we say P implies Q equals 0 here. But based on the assumption, and we actually get the P implies Q equals 1. So you cannot have both. So this is a contradiction. So we prove that this must be 1 and this must be 1. Okay. Now here's question 4. We try to simplify the following Boolean expressions using Boolean identities discussed in Module 2. Let's take a look at the 4a. Okay. So now this problem is not an easy problem. Okay, I have to say that. But we can do something with it, right? Now I find out the easiest way to do this is, let's say A plus C times tilde A plus B times C plus B. Now we find out the first item and the third item both contain C. So then we can say, let's say, we can A plus C and then C plus B times tilde A plus B. Now we actually switch these two items. Why we can do this? This is commutative, right? Commutative law. So we can switch the order because this is actually the AND operation. And then we can both contains C, so we can move C to the front also by commutative law. So times C plus B times tilde A plus B. Okay, also same reason. And then this is actually the bigger one. So we can have C plus A times B. Okay, that's by the distributive law. Okay, now a lot of people actually forgot these parentheses, because when you actually do the distributive law, now you have to make sure the result will be in the parentheses. Why? If you don't put the parentheses based on the precedence of the operation, so you have to evaluate the AND operation first, then the OR operation. Okay, so this is going to be actually different. So you have to actually evaluate the OR operation before this AND operation. Okay, so you have to put the parenthesis. That's going to make a big difference. Now, once you have a parenthesis, then you can actually multiply things out. So C times A, so C times tilde A, actually tilde A, and then C times B, right? So plus C times B, and plus A times B times A, right? Oh, actually times tilde A, plus A times B times B. Okay, that's also a distributive law. Okay, I'm not going to write this. So then we have C times tilde A. Now the second term, for the second term, you find out, you can put the C times B, and then you can switch this order, right, by the commutative law. So then you can say A times tilde A times B plus A times B times B. I can just use the commutative law. I just multiply B times B first. Okay, so then this is going to give you C times tilde A plus C times B. And what do you get? A times tilde A. That's a AND operation. So this is 0, right? 0 times B plus B. You got A, 1B, right? So this is going to be canceled out. So now you have 3 items. Okay. Now most people actually stopped here, and in the quiz, if you actually reach that result, I'm going to give you full grade. Okay, but you can continue to do it. You can continue to do it. How are you going to do this? Okay, let's do a small trick. C tilde A plus C times B, and then use the I'm going to put the tilde A plus A, because tilde A plus A is 1, right? So then plus A times B. So the middle one, I just multiply 1, which is A tilde A plus A. So then you can continue. So use distributive law. I got a C times tilde A plus C times B times tilde A. Okay, plus C times B times A, right? Plus A plus B times B. Okay. Sorry. So let me actually erase this. Let me just put more clearly. Okay, so the last one is C times tilde A, C times B times A plus A times B, right? So now use the commutative law. I can switch the order between B and the tilde A. So then I can get the C times tilde A plus C times tilde A times B, right? Now I can put the parenthesis here, Now the second one, there's A and a B, A and a B. So I can put the A times B times C, use commutative law, I can switch the order, and times A times B, right? I can put the parenthesis here, and then use the distributive law, or you can use the yeah, I think you can use distributive law. C tilde A, take it out, right? And then here's 1 plus B. The first one is 1. Yeah, the first one is actually, you can say C times 1, right? The second one, A times B. This is a common, factor. So I can take this out, and the first one is C, right? And the second one is A times B times 1, right? It's the same. So it's C plus 1. Now, 1 plus anything, just 1, that's the, remember, that's all operation. 1 or B, that's also 1, right? So that means C times tilde A times 1 plus A times B times 1. So now you got a C times tilde A plus A times B. Now that's the bad result. Okay, so this is actually okay, but it's not the simplest form. That's the simplest form. Okay, so but if you got this point, then yeah, I will give you full credit for this. Okay, so that's the first question, 4A. Now, I think the second one is relatively easy, and most people got this result correctly. So 4B. So now, if you look at this, what do you get? This looks like you can use the distributive law, right? Okay, so A plus B times tilde A plus B times tilde B. So now if I switched order, I can put the B plus A times B plus tilde A times tilde B. Now I can use the distributive law. Okay, so this is going to be B plus A times tilde A, right? So I take a B, the common factor B out, plus A times tilde A. Now, remember, you have to put the parenthesis here before the tilde B. So this must be, you have to put the parentheses. So now A times tilde A, that's 0, right? So you got a B plus 0 times tilde B. Now again, B times 0 plus 0 is B times tilde B. What do you got? You got a 0. Okay. So the result is 0. It's false. Okay, now here's question 5. Draw the circuits of the Boolean expressions in problem 4. Now, I have a 4A and a 4B here. Okay, so I just copy the two expressions over here. So that's 4A, that's 4B. Okay, let's take a look at A. Okay, so now we have one AND gate, OR gate, one OR gate, one OR gate. So you have a total of 3 OR gates, and you have 2 AND gate, and I have a 1 NOT gate, right? So basically I have 3 inputs. Okay, now the first input, A, second input B and C. Now the first OR gate have an input A and a C. So let's say I'm going to put the first OR gate here. I have an input A, and also I have an input C, right? So what I'm going to do is, so I'm going to actually put the input C here, and let's say, okay, so it's coming from C, okay. So I'm not connecting at this moment. Now the second one is the tilde A plus B. So then I'm going to use the second OR gate. Now the second OR gate use the B as an input. Okay. Now the other input is tilde A. So the A need to pass through the NOT gate and then connect to it, right? So that's tilde A, right? So that's B. So this is going to be tilde A plus B, and this is going to be A plus C, and the last one I have a C and a B. Okay, that's B, that's C, so that's C plus B, right? Now the first one is A plus C, so I'm gonna go C. So then I'm gonna go here, pass twice. Okay, make sure they don't, intersect. So I just use a small curve. Okay, so that's C. So then we're gonna go into the AND gate. So you can use a 3 inputs AND gate. So it's very quick. So you can just do this, right? Use 3 input AND gates. So this is going to give you the final result. Okay. So now let's look at the B. Okay. So for B, we only have 2 inputs, A and the B, right? So the first one is the A and the B. So the second one I use tilde A and the B. Okay. So now I have the first OR gate, the second OR gate. So I have 2 OR gate. Okay. 2 OR gate. Okay, the first OR gate is input A. Okay. Now so I'm gonna use B. Okay. So this is gonna give you A plus B. Now the second one is tilde A. So that means I need to go through an OR gate, a NOT gate, and then use this. The output of NOT gate is going to be the input of the second OR gate, right? So the second OR gate. And then I'm going to use B. So that give you the tilde A plus B, correct? Now the last one is the tilde B. So then I'm going to go over here. So this is going to give you tilde B. So now I have A plus B, tilde A plus B, and tilde B. And all these 3 items going to be, go into the AND gate. Again, it's a 3 input AND gate. Okay, so that's the phi B, the second circuit for the Boolean expression B.